Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 7, 7.8, and we're considering three-dimensional coordinates. Now, we have already considered three-dimensional coordinates in previous lessons, so a bit like the last lesson, there's nothing fundamentally new in this lesson, although the two different ways of thinking about finding the magnitude of a vector or the distance between 2 points, it may feel slightly new. So three-dimensional coordinates, they're described by adding a third direction z, which is perpendicular to both the x and y axes. If we consider a point, 3, 4, 5, 3 is the distance from the origin to A in the x direction. So it's how far A is to the right. 4 is the distance from the origin to A in the y direction, so how far it is away from us. And 5 is the distance from the origin to A in the z direction, how far it is vertically upwards. To find the distance between 2 points, x1, y1, z1, and x2, y2, z2, we use Pythagoras. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay, let's do an example. Find in surd form the distance between the points A, 3, 5, 6 and B, 7, 2, 1. No tricks or catches here. Have a go yourself, pause the video, come back to me when you're ready. Okay, let's have a look. So substituting in the values to the formula, it's the difference in the x values squared plus the difference in the y values squared plus the difference in the z values squared. That gives us the square root of 4 squared plus minus 3 squared plus minus 5 squared, which is root 16 plus 9 plus 25, which is root 50, which would simplify to 5 root 2. Now, it's worth noting the similarity between this, the extremely close similarity between this and finding the magnitude of the vector that joins A to B. So the vector AB is given by the position vector of B, take away the position vector of A, which would give us 7 minus 3, 2 minus 5, and 1 minus 6. And if I then want to find the magnitude of that vector, then again I use Pythagoras. I get the square root of 7 minus 3 squared plus 2 minus 5 squared plus 1 minus 6 squared, which it's essentially exactly the same method as finding the distance between 2 points using Pythagoras. Again, we get 5 root 2 for the answer. A special case is finding the distance of a point from the origin. So example 2, find the distance from the point A, 3, 5, 6 to the origin, 0, 0, 0. Again, no tricks, no catches, have a go yourself. Pause the video, come back to me when you're ready. Okay, let's have a look. So we'd do the square root of 3 minus 0 squared plus 5 minus 0 squared plus 6 minus 0 squared, which is the root of 3 squared plus 5 squared plus 6 squared, which is the root of 9 plus 25 plus 36, which is root 70. And again, note, the position vector of A is OA, which is 3, 5, 6. And if we then find the magnitude of that vector in the normal way, it's exactly the same thing as finding the distance between A, 3, 5, 6 and the origin 0, 0, 0. And we get exactly the same answer. Okay, that gets us to the end of this lesson. If you've got the textbook, turn to page 125 and have a go at exercise 7H. Thanks very much for listening and cheerio.